In this lesson we're going to look at the reaction of metals with water. Now, how a metal reacts with water depends upon its position in the reactivity series. So if we start at the top, we can assume that the reactivity will gradually decrease as we move down the series. In fact, once you pass hydrogen, the metals are no longer able to react with water, so we can write no reaction here. But if we take the first 5 elements, potassium, sodium, lithium, calcium and magnesium, they will react with water to produce a metal hydroxide and hydrogen. For this reason they are known as the alkaline metals. Let's write the general equation. So we have the metal plus water produces a metal hydroxide plus hydrogen gas. Okay, so if you just look at these photographs here at the top, you'll notice that we have potassium, which is whizzing around on the surface of the water, rapidly producing hydrogen, and so much energy is produced that that hydrogen ignites to produce this lilac coloured flame. Next on the list is sodium. Well, that whizzes around on the surface of the water, but it doesn't tend to produce a flame, it doesn't ignite, but there's still a lot of energy released. In the case of calcium, well, the calcium sinks to the bottom of the flask, but it will react vigorously with water. And well, magnesium, this is a magnesium ribbon, and that's been placed in this cold water, and you'll notice that after a while bubbles start to appear on the surface of the magnesium ribbon, but this is really a very, very slow reaction indeed. So we can say that these elements react with cold water with decreasing reactivity. Let's just take an example then, for example sodium. So we have sodium plus water gives us sodium hydroxide plus hydrogen again, and then we can write the symbol equation. So we have sodium plus H2O for water gives us sodium hydroxide plus H2 for hydrogen. Now let's just write that. We'll put AQ there because this is an aqueous solution of sodium hydroxide, and you'll notice that at the moment the sodiums are balanced, the oxygens are balanced, but the hydrogens aren't. We've got 2 hydrogens here and we've got 3 on this side. So what I'll do is to balance this, I'll do a little trick. I'll put a half there. Okay, now the equation's balanced, but you know you can't have half a hydrogen molecule, so what we'll do is we'll multiply everything by 2 to get rid of the half. So we have 2 sodiums plus 2 waters plus 2 sodium hydroxides. The 2 times a half goes, giving us 1. And then this can then be tested with indicator solution, and it will turn a sort of purple colour indicating the presence of a strong alkali. And with respect to the release of hydrogen, well, you will notice that as you move down this series here, the speed with which hydrogen is released in this reaction decreases as we move from potassium to magnesium. Okay, so after magnesium we have aluminium, and aluminium should in theory react with water, but it gets covered by a protective oxide layer which renders it unreactive when added to water. So this protective oxide layer sticks to the surface of the aluminium and stops it reacting with the water. Now after that we've got zinc, iron, tin and lead. Well, these will not react with cold water, but they will react with steam. In fact, magnesium really needs to react with steam in order to get a reaction going. Okay, so when these metals react with steam, then we get, this time, not the metal hydroxide, but the metal oxide plus hydrogen. So let's just take, for example, the reaction of zinc with steam. So we're going to get zinc plus H2O, that gives us zinc oxide plus hydrogen. And the oxide that is formed is usually insoluble in water.